Today we're going to be talking about this formula over here and what else we can do with it. So this, when x is smaller than 1, and only when it's smaller than 1, we have it so that xn, or in the sum of xn, where n is equal to 0 to infinity, is equal to 1 divided by 1 minus x. This is obviously true because that's just geometric sequence, and geometric sequence is just like that. This is also just the same thing as this over here. Now, if we take the derivative of this over here, we're going to get this over here. Now, if we do derivative on this side, we have to do the same thing on the other side. So if we take the derivative of each one of these, we're going to end up with x0, which is going to be equal to 1, which the derivative is going to be equal to 0, which is over there. X1 is going to be over here, x squared over here, and so on. Now we get that this 1 divided by 1 minus x squared is equal to 1 plus 2x plus 3x squared plus 4x. You get the point. So that's really interesting. But we can just keep on doing this, actually. So the derivative of this over here is this divided by 2. So if we just have this over here, that means we have to divide the other side by 2 as well. So the other side will be the derivative of this times 1/2, which is 1/2 times 2 times 1x, 3 times 2x plus 4 times 3x squared. You get the point. But since all these are obviously have to be even because it's multiplied by this n times n minus 1, we can just divide all of it, and we're going to end up with this over here. And when we keep on going, we're going to realize that this is what's happening. When we have 1 divided by 1 minus x to the k power, this is equal to k minus 1 divided by k minus 1, k and k minus 1 times x, and so forth. So this is our formula that we're going to be using in today's problem. By the way, this is also just the same thing as this over here. So let's move on to our problem. Here we have s being equal to I, j, and k, was the sum of it being equal to 17, and all of them being greater than or equal to 1. We have to find this over here. Now, first of all, this is just the sum of the products of I, j, and k, where it's equal to 17, of course. So first of all, since we know it has a fixed sum, then we can make a function with n being equal to I plus j plus k, and we had to look at it where n is equal to 17. Since this has an infinite amount of constants, we're just gonna be looking at where x is equal to x to the n power is equal to x to the 17's power. So since n is equal to I plus j plus k, we can turn it into this over here. Now you'll notice that we also turn this n over here into I, j, and k. So what can we do with this from here? Well, let's just turn it into we're going to generate 3 separate functions. All this being this over here, this one over here, and this over here. You'll notice that these are very similar actually. There's the only difference between the variable, which is we actually don't really know, so there's quite literally no difference. So this should look familiar because we already figured this out. So let's just put that in where each of these is equal to x divided by 1 minus x squared. Cube it, because there's all 3 of them, whoops. And we're going to get that this is equal to this over here. Now, if we take x to the 3rd power out, we're going to be left with 1 divided by 1 minus x to the 6th power. Well, what did we just do before? Well, we know that this is going to be equal to, this over here. So Now, what do we want to find out in the first place? Well, since we know that I plus j plus k is equal to 17, we have to make it so that x to the n power is equal to x to the 17th power. So let's just do it here, shall we? So since we have to make the entire equation have x to the 17th power, we have to make this 14, because here we already have a 3 and you're not really going to get it from anywhere else. So put 14 as I into here, and we're going to get that this over here is equal to 19.5, which is also equal to 11628. And there you go. That's our answer.